This is Colorado Matters from CPR News and KRCC. I'm Ryan Warner. Spring has sprung. Should we expect flowers or flurries? Chief meteorologist at Denver 7, Mike Nelson, is back for our regular weather and climate chat. Hi, Mike.
Good morning, Ryan. I tell you, spring is what we expect pretty much everything. Just the other day, we had heavy snow in the mountains. We had strong winds over southeast Colorado with temperatures in the 80s and grass fires. Temperatures in Denver only in the 40s, and we had a mix of rain and snow. And my favorite, graupel, the little dipping dots that come from heaven, that little soft hail. So that's a typical spring day. I mean, that was all at the exact same time.
My goodness. And we can expect that for the next month or so?
Yeah, it's a very unstable time of year. There's a big change happening right now across the country as the sun gets higher in the sky. Of course, it's getting warmer across the south, so we get more of that moisture coming up from the Gulf of Mexico. But the cold weather doesn't want to really give it up yet, and so we have a real clash of the air masses every year. But it seems this year, a particularly supercharged jet stream that's been bringing all these big storms in from California. At the same time that we had all that weather the other day, Los Angeles had a tornado. I mean, this is a crazy time of year.
I do think of this time as particularly snowy historically. Well, tell me if that's true, and two, tell me what the forecast might show.
Well, the 30-day forecast is still calling for slightly colder and wetter conditions. That would take us through about the middle part of April. And I think that is true, although we have not seen a lot of snow here in the Denver area this March. The mountains have just been getting pounded. I mean, the San Juans have some of their highest snow totals they've had in over 35 years. So there has been a lot of snow falling, just not right here on the Front Range. April is still one of our snowiest months on average here along the I-25 corridor. So that could indeed change in the next couple of weeks, that we could get a couple of good soggy snowstorms.
The vernal equinox is the start of spring in the northern hemisphere. Let's get maybe elementary about this. Vernal means related to spring, by the way. What precisely is going on, like astronomically?
Well, as the Earth goes around the sun, because it's tilted on an axis of 23.5 degrees, there's certain times that the North Pole is tilted away from the sun, which would be wintertime, more toward the sun in the summertime, and we're right in between now. So it's about 12 hours of daylight, 12 hours of darkness.
Back to the notion of snow. How's the snowpack, which is really one of our largest reservoirs, holders of water for the warmer, drier months?
It's very good right now. Every major basin that we serve, Colorado and the Arkansas and the San Juan, et cetera, all of those are above average on snowpack. There's some areas, especially down in the Southwest, that are almost 200% of normal, which is great news. It does open up the concern about snowmelt flooding in the spring when the warm temperatures really start to bring that snow down in a hurry. But I also think it'll be interesting to see just how much that impacts Lake Powell. Now, it certainly is not going to fill that reservoir back up. I don't think we'll ever probably see that again, but at least it might bring it up a little bit as we go into the warmer months this year.
And Lake Powell is an important water savings account. All right. You began our conversation with just the symphony of strange weather that we're seeing. How much is that typical of spring? How much of that might be intensifying because of climate change?
Well, as we've talked about before, weather and climate are related, but they are two different things. And the analogy that I always like to use is that weather is like one play in a football game, and climate is the history of the National Football League. But as the climate system gets warmer due to the increase in carbon dioxide from the burning of fossil fuels, and we add 100 million tons of carbon into the atmosphere every single day globally from the burning of fossil fuels, that carbon acts like a blanket, and that traps heat from escaping back into outer space. So the whole climate system is warming. As it warms, that means that the air can hold more moisture. We've talked about these atmospheric rivers. You hear about that on the news quite a bit. And moisture plume that's coming in from the Pacific Ocean, that's getting supercharged because of a warmer climate. And so the weather that we've seen pounding California this year because of the position of the jet stream, which drives that atmospheric river, also has an impact across the weather conditions all over the nation. So with climate change, everything gets bigger. Droughts get drier, floods get wetter, heat waves get hotter, and you can even change cold waves a little bit because the jet stream shifts a little, and once in a while these colder pools of air can break free from their normal Arctic home and drop farther southward. So as much it would seem counterintuitive, with warming, you can actually have regionally colder weather for a period of time.
Mm.
Everything just gets, it's like it has been called global weirding. And I think that's a
Ah,
very good phrase.
right, because it's not exclusively warming, as you say. Okay, so there is a difference between these atmospheric rivers and the jet stream. I just wanted to get clear on that distinction. They're related, but they're not the same thing.
Well, the jet stream, think of the jet stream as a great big river of air that goes all the way around the world, bending and twisting and turning. The storm systems kind of float along almost like a barge in that river. And
Mm.
so when the jet stream gets in a certain position and you get one of these big plumes of tropical moisture that's coming in from the Pacific Ocean, say all the way from Hawaii, that'll come crashing right into California. You're just bringing this big boatload of moisture into California. And I've seen studies that say the amount of water that comes in with one of these big atmospheric rivers is the equivalent of the Amazon River.
Oh my goodness. There's a lot of discussion underway in California right now about whether there should be infrastructure to capture all that water in a place that's often in drought. So, is this a power that could be better harnessed? Um,
I think there might be something to that. Now, right now, if you go out there, I mean, the Los Angeles River is, you've seen it from like Terminator 2 in Greece. It's concrete and it just
yeah.
carries all that water out to sea. Would there be a way that on the occasion that you get this massive amount of fresh water coming out of the sky, that you could capture that and then clean it up and use it as a resource rather than it pouring out into the ocean? I'm not an engineer, but it seems to me that would be something to be looked at.
Mike Nelson, in between our chats on the radio, we'll sometimes send each other studies or articles that catch our attention. You shared one about wind and solar power as they relate to land, to property, really. This is research out of Colorado. Just tell us about, well, what caught your attention?
The little amount of land it would take to actually switch our nation completely over to renewable energy. And the study was from the Renewable Energy Lab up in Golden, and it said that when you actually look at the footprint of what it would take for solar panels and wind turbines, it's very, very small, 1 or 2% of the land mass in the United States. And think about a giant wind turbine farm. I mean, you can still have cows grazing amongst all of that, turbines spinning up above. They're looking at putting farming in between the photovoltaic cells in some areas so that you could grow crops underneath the solar panels. You can have sheep grazing underneath the solar panels. So these things can all coexist very, very nicely. And it is actually, we are able to provide renewable energy to power the country because it is always windy somewhere and always sunny somewhere on a big enough scale. You just have to capture that energy that comes in free from the sun and transport it via good transmission lines from source to need. We can do this.
Why is it important to think about the land footprint of renewables? I know this article compared it to traditional fossil fuels, Mike.
Well, it's important because we do have the space to get this done, and we have all of the technology. It's just a matter of the will and the leadership to get it done. So that's the part that I try when I speak to schools, when I speak to other groups, and when I talk here with you every month, is the fact that we actually can fix this problem. Climate change is big, but big problems need big solutions. We can do it. And what was surprising me was that the amount of land to do it is not as big as you would think.
Mm. Maybe the kick in the pants, so to speak, is what we heard from the world's climate scientists this week, a final warning on the climate crisis. The UN Secretary General calling it a clarion call to massively fast-track climate efforts by every country and every sector and on every time frame. Our world needs climate action on all fronts, everything, everywhere, all at once. I guess invoking the movie title a bit there. Mike, when things are this bad, people might have an inclination to bury their heads in the sand. And I am curious how you, as a meteorologist who's on TV, who indeed visits classrooms, how do you fight against that propensity to just kind of tune it out because it gets so dire?
There's a message that I will not take credit for because I learned it from Dr. Scott Denning up at Colorado State University, who is just a brilliant climate scientist. Climate change is simple. Add heat, it gets warmer. It's serious for all of the issues that we talk about, the drier droughts, the heavier flooding, sea level rise, melting of the ice caps, but it's solvable. We can fix this problem, and we have the technology. We just need the will to get it done. I always say that the physical science of climate change is pretty simple. As I mentioned, add heat, it gets warmer. The political science of finding the solutions, that's a heavier lift, but we can get it done. And the reason I speak out about it is because we need all of us to let our leaders know that this is an extremely important problem. Whenever they say, when we do a survey of people and they say, what are you worried about? And we've got immigration, we've got the war in Ukraine, we've got the cost of goods, we have inflation. Look at climate change is way down here. It's like number 10. That's because they're asking the wrong question. If you're concerned about all those other things, you're concerned about climate change, because climate change is a threat multiplier of every single one of those other issues.
I like the idea of keeping our eyes on the fact that the problem of climate change, the fact of it, the science of it, is really quite straightforward, in contrast to the political science, as you say. Mike, thanks so much. Nice to chat with you again.
Ryan, always a pleasure. We'll see you next month.